This is the Nomad Futurist podcast, a podcast about the evolution of technology, society, and transformation. Connect with us, share your thoughts with us at nomadfuturist.com. Let's get this started. Here are Phil and Nabeel.
Hello. Welcome to Nomad Futurist. This is your co-host, Nabeel Mahmood from Scottsdale, Arizona.
This is your co-host, Phillip Koblence from Montclair, New Jersey.
Greg Ratcliff from Central Ohio.
Greg, thank you so much for taking the time to join us today. It's been way past overdue. And I got to tell the audience there is something very interesting. I've only known Greg for maybe about 20 years of my life. Long history. And this has been way overdue. So Greg, before we get started, could you share with our audience at a very high level, what do you do?
I walk around to the business giving gifts to engineers and technologists. At the highest
He's Santa
level.
Claus. He's Santa Claus.
I am. For engineers, I am Santa Claus. So I lead innovation globally at Vertiv. And one of the things I do, and it's so rewarding, is I gather technology from startups, from universities, from other businesses, from even the most sophisticated customers and clients, package it up and allow our internal technology teams to leverage that for new products and designs. Probably the coolest job in the world, and it's definitely the coolest job I've ever had.
Well, I would say I've never heard anybody say the way you explicitly narrated what you do for a living, giving gift of education. And by the way, this is not necessarily a plug. I've had a long relationship with Emerson and Vertiv. So I just want to give kudos to Vertiv for giving me that rack. It's pretty cool. We're going to be taking it out to schools. And that actually came from the Vertiv team in Asia Pac. So thank you very much, Tony, and the Vertiv team.
How are you going to get little tiny servers for that rack?
We'll get, you get the...
we're going to have to call somebody at NVIDIA and make some calls to Dell or somebody else.
That mini rack is going to have like a 3-phase receptacle associated with it.
Raspberry Pi.
And if NVIDIA has its way. I just want to make sure that Asia Pac doesn't get all the plugs here. So feel free from Central Ohio to send one of those little racks to your friend here in Montclair, New Jersey. I'd love to display it as well.
Yeah. As a matter of fact, we need to get it on the road show. So, Greg, we have known each other for a long time. For ages. Before we get started, could you share, how did you actually get into this sector?
Yeah, I've been a technologist my entire career. I've told this story a few times, so I'll see if I can condense it a bit. I was a young engineer at the Ohio State University, and I recall so well the assistant dean sat down with me and said, Greg, we don't feel you're cut out for engineering. Maybe you should move to mathematics. And I did. And about 6 months later, that same dean was passed over, assistant dean, to the dean of the School of Engineering and got a little upset, let's say, and decided to go out on his own and start a company to do microprocessor development. In those days, microprocessor development were two words that you could not string together without them stumbling, coming out of your mouth. And so we started this business. In one regards, it might have been a huge mistake. While I was finishing up school, my plan was to go to the Air Force, and I had all of my ratings. So I had my private, commercial, instrument rating, instrument instructor, flight instructor rating, and was just starting on my multi-engine. And I got this call from the former assistant dean at the Ohio State University that he was starting this business. And 3 young graduates and disgruntled assistant dean are not who you should go into business with. Let's just be clear about that.
It's rare that businesses that start out of spite succeed. But are you saying that the same dean that told you you're not cut out to be an engineer called you to hire you as an engineer?
Exactly. It's my first thing was in those days, it was like this. Should I just hang up this phone and head over to the Air Force? But I didn't, because I really had this hobby of doing programming, and I was laying out circuit boards, which probably led to some of those problems at school. and we landed a pretty big contract with Microsoft and CompuServe to do some hardware for CompuServe in the early days of the internet. And it was wildly successful for a minute.
So that's what 85, 90 timeframe, is that right?
Yeah, exactly.
For those kids that are listening, CompuServe was a service similar to Prodigy, or the kids might recognize America Online from the AOL.com email addresses that still exist that people use to dial up to get to the internet. And yeah, exactly.
So we did all this engineering work, and we started to get a reputation as pretty responsive, and we could put hardware and software and microprocessors together and turn them around real quickly. There was this company just about a mile from us that was named Liebert, and the global vice president of engineering at Liebert, God rest his soul, he's no longer with us, but he was a tall force of nature, let's say. And he came into our office the very first time using language that I had never heard growing up. And he's a little bit angry, and he has a cardboard box with drawings and parts. And I didn't really know what Liebert did. And so he brings all this stuff, and can you design this thing? We have 5 weeks. The engineering team has let me down. And so, young man that I was, absolutely, sir, as I'm trembling before the Wizard of Oz, kind of. And that started a very long relationship of us doing work for Liebert in a contract basis.
Was that like during your control state?
Yes, we were doing controls, little displays, small circuit boards that weren't core that were holding up projects. And one of the things that happened over that sort of long relationship is Mike and we talked about it, and it was like, man, those guys at Liebert are so difficult. I'd never want to work there. We'd call them up and ask for help. And as it turns out, they were under tight schedules. Those engineers wouldn't give us much time. So we're trying to get help to try to finish their project, and they were kind of like off on the core stuff. So fast forward a few years, the company is tremendously successful through growth, some organic and mergers. We end up being about 1,500 people.
The Spike company worked out.
Yes, it did. Yes, it did. And ultimately, through, again, some other acquisitions, it became GE Power. So General Electric buys that business, and a fair number of us don't want to go to GE. We love what we're doing. And so lo and behold, a few of us started making calls to this company, Liebert, that we would never work for. And at the time, it was Emerson Network Power. And a few phone calls later, an entire group is formed. It does monitoring. We did sort of the first PPP IoT stuff in data centers was our stuff. Can't go down. And so monitoring the air conditioning and the UPSs 24 hours way before it was called IoT was what that group did. Was pretty exciting.
You invented IoT, basically. I mean, it's
kind of.
That was back.
I'll share with you, Phil. The first IoT came from New York City, and they put relays with counters on elevators when they took the elevator guys out. Well, they had a name for those guys. I don't recall what it was, but all elevators used to be manned, and people were in there, and they would run you up to the 5th floor. And when they took the people out, they added monitoring systems that would dial phones. After 10,000 transits, they would report in and say, time to grease the elevator. So that was the first IoT.
I do see a common thread, right? You have this person that doesn't think you're capable of being an engineer that calls you after opening up Spite business because the school didn't think he could be the dean. And then you end up going to this engineering thing, and then end up going to a company you would never want to work for, so that you can, I guess, continue to do what you loved from within.
Maybe that's an example of poor judgment on my behalf.
Clearly, it's
all
worked
of them
out.
were a lot of fun and really grew my career, but I was like, no,
I would say it's poor judgment if it was just you. It's not just you. It's the school. It's that guy. It's you. It just, maybe that's just something's in the water in Central Ohio where you just go against whatever your feeling is, do the exact opposite. And that's where success is.
Or maybe the other way to put that is actually Greg is one of the change agents. I'm going to make a difference and contribute. So the glass is half full.
Thank you.
This is where we meet, roughly about 2003-4 timeframe.
That's right. Right. Brand new monitoring group. The company is just exiting the telecom wreck, if you will. And the trajectory is not dramatic, but it's positive and growing, and new technologies making it into Emerson. And we're looking for direction. And thanks, Nabeel, you were part of that contribution of where are we now? Are we everything in data centers? Are we going to stick with infrastructure and grow the business? And our group that we manage, the monitoring group, I'll just say It was a lot of fun as a career. And just a little bit, if anybody's thinking about embedded hardware and software as a career, that becomes school for everything, because the embedded systems make their way into electrical systems, mechanical systems, electromechanical systems. So it's a great broad first way into a business, no matter what it is. In the data center space, the connectivity is everything.
So not that we want to shoot that horn, but one of the things that I clearly and explicitly remember back in the day, for it being proprietary, for it being complicated, for it being something very new, and being in the data center space, trying to sell data and leveraging data that is trying to eat our own dog food was practically impossible. Could you share, again, from a market perspective, of how we've come along and why and how it's actually become a major part of what we do today?
Yeah. So from a data perspective, I think the big thing to keep in mind is that time matters. So as the power systems became more and more critical to the operation, you needed to have an immediate alert that the UPS was on battery and that the infrastructure was at risk. So the values changed pretty rapidly as the runtimes for UPSs became 20 minutes down from an hour. And that technology shift, I think, made a big difference. I suspect there's another thing that started to occur about that same time is the complexities of the air system to gain efficiencies, that they weren't independent air conditioning units for rooms. They became an ecosystem where they collaborated and shared information, and they needed orchestration. And if you're going to have a single orchestration for a computer room, then somebody should be managing it and watching it. So I think that's what drove the real value. It definitely was power and cooling at about the same time for different reasons.
Yeah, at some point too, you have to realize that it's not just the clients in these rooms that are creating data. It's all of the equipment that we're putting in there that needs data that's manipulated. And now if you could fast forward 30 years or maybe slightly less than that from the time you guys met to these BMS systems, which are single-handedly managing a full range of environmentals and power conditioning, modeling what happens in certain sections, doing real-time computational fluid dynamics and understanding how airflow works in a data center. It was originally just blow cold air where the computer is and everything will probably be fine. And obviously, the more things evolved, the more detailed that set of data became and the more tools needed to be done.
You triggered a thought. I'm reminded that as the data centers grew in size, they were basically computer rooms built out of old central offices. They started to become purpose-built and grew in size. Nobody wanted to walk around to 100 air conditioners and change their set point. And data center operators love to have their hands on their gear. So it's like this other value is it saves steps and I can still have my control.
It's amazing how much innovation is born out of sheer laziness.
Right. True.
Greg, before we get into more techie stuff, one of the things that I'm always very curious about, how did people get into the sector, right? So you obviously have a mathematics and or technology engineering mindset.
Really more mathematics than engineering, according to the not so dean of the University of Ohio Engineering School.
Well, look at me now. So going back in time when you were a young man, were you exposed to the sector or were you exposed to technology? I mean, what drove your passion and or direction for that matter early on in your life?
Early on in my teens, everybody perhaps has this uncle, the odd uncle in the family. I had the odd uncle in the family that always had his camera around him with a really big lens. And he always had this sort of walkie-talkie thing on his belt, and it was a ham radio. And so in those days, it was kind of a big thing, not like a cell phone. It was a giant battery-powered thing with an antenna sticking out of the top. And at one point, I was probably 13 years old, I had mentioned to my mother that I was interested in electronics. And like a week later, my uncle shows up at the house with a shortwave radio and a wire antenna and a Morse code key and tells me to start practicing my Morse code. and spends time with me. Basically, as in the ham radio folks, it's called an Elmer. It's a mentor that gives you gear and takes you through the process. Well, this engineer, I think there's a picture of a shuttle back there. Yeah, right about there on my screen. That's the space shuttle. My uncle was a hydraulics engineer for Rockwell and did a bunch of control systems. And so he got me into control systems and electronics and building things by hand. I have his TTL box that has one of every 7400 TTL chip in it. And to this day, and so he really brought me up from a hands-on electronics. You might write some code, figure out the logic, make the hardware do what you want. And later on that became code. So that was the beginnings of that. And I suppose that's why I ended up with that mathematics job that wasn't a mathematics job, because I was laying out circuit boards part-time. I was wire wrapping things. I was a hardware guy back in the day.
If you can't think of an uncle that you have that fits that description, you might very well be that uncle.
No, I think I am that uncle now that I'm that hurts, Phil.
Sorry.
I'm the odd uncle at the family.
I think my family would probably agree, all my nieces and nephews, that I might be the odd one. So I'm right there with you.
Well, it's all right. The entire Nomad Futurist sounds like, based on that definition, to be the one.
Got uncles and aunts coming together.
What was the name of the program again, Greg?
I'm sorry, which program?
The Morse code program.
So ham radio operators back then had to learn Morse code with the dits and dashes in order to get their dashes to get their license. And once you had your license, it was a license to experiment, because in those days you built your own hardware and transmitters. In high school, I built a whole receiver and transmitter set because that stuff was expensive. It was many, many thousands of dollars back then to buy commercial ham radio gear, and it was all handmade.
So I think in a way, history repeats itself. Where we stand today in time, we have to do the same thing. We've got to be these mentors. We've got to share our story. We've got to be that weird uncle and aunt and encourage the young generation to get into our sector. With the advent in technology and where we're at today, just in the last 20 years that we've been working together, where do you think we have the biggest challenge today? And as we sit where we're today, what do you think would be the next biggest thing in the next 3 to 5 years?
I think the sort of a problem that exists in our whole world of engineering for our market that we're in, it is that there's not quite enough systems thinking. There's build these things very well, build a great distribution unit or a UPS or a generator or a solar array or a BESS system without thinking about how they have to interact and collaborate with each other. Not just I'm feeding power to the next thing in line, and it's that thing's problem, or we're cooling in a different way with liquid cooling. So I think there's a gap in systems thinking, in systems integration. There has to be a multitude of companies, right, that provide these products to the industry, but people need to have, engineers and technology folks need to be thinking from day one that this is going to integrate with another system, not be an island.
Yeah, I mean, I think it's a brilliant thought, and I think it's emblematic of how we teach technology and how we even onboard employees in the various companies. Everything seems to have fallen into this more traditionalized, compartmentalized approach. Like, this is your job. This is all you need to worry about. You do this. These are your KPIs, as it were, and don't think about anything else. Where the makings of future leaders in our industry, and frankly, any other, really have to understand the kind of 30,000-foot view, not to step on your Cessna conversation earlier, and understand how everything interacts with every other part of the business. In order to be the best engineer or technician, you should really understand how people are leveraging the stuff that you're doing, how the company monetizes what you're doing, how the overall business is underwritten, and what the motivations in various groups are.
That's right. Yeah, like I said, I have a pretty good gig. I drag engineers and technology folks together and make the thermal folks listen to the power folks and make the accountants listen to both of them. So
is there resistance there? Do they want to listen to it? And do they know why it benefits them?
Yeah, they do. That maybe sounded a little bit snipey. It's that they want to do their job, not to talk a lot about Vertiv, but our superpower is execution. And so folks that are in one part of the business are just so focused on doing the best they can for our customers, then they might not learn about what's going on elsewhere. And so we have dedicated times for those. Something that just came into my mind I have to share is about once a month, we have a great community in the data center world in Central Ohio. It's not Northern Virginia, but it's growing. It's really dynamic. There's a lot of interaction. And so our teams inside the company get invited to see Vertiv equipment in action. So last week I had attorneys, finance folks, power and cooling, of course, and a lot of young engineers that I wanted to give them the motivation of what happens to all your good work, no matter where you are. And to see customers excited about this thing goes down for a millisecond, all that 10,000 feet of data center goes down. It really matters what you guys do, and we love it. So we get to drag them out of the office environment into data centers, walk on the white space, see the servers. Right there is the cloud for XYZ company, right? Right there is where one of the big hyperscalers have all the rest of our data center. And to see it in action really makes it real for our technology staff.
Absolutely. I think you bring a great point, right? So one of the charters that we've got as a foundation is the fact to demystify technology and break these barriers that we've got, right? The electrical, mechanical, structural, networking, finance, legal, they should all be talking. So you giving that example to adults that are in the space from different verticals or sub-verticals for that matter that are from our space. I mean, the implication eventually hits the CFO's desk or the legal counsel. And those are not the people that you actually want to be having a conversation with when it all crashes. Where do you think we're headed? I mean, what's the next big thing from your experiences thus far? I mean, compute densities have increased a lot. ChatGPT, Gemini, and others are becoming muscle memory. We're using more and more technology gear. Everything is going to be connected. I mean, I actually...
Much of it being deployed in Central Ohio?
I mean, 9 billion people by 2050 are going to be connected. There's going to be this internet bubble. Where do you think we're headed? What's the next big thing that's going to happen between now and then as it entails to the redefinition of data centers?
You know, when we first met, we thought edge was going to be something that happened. We've been talking about that for about 20 years. I got to see a demonstration of an AI-driven welder that could weld things it had never seen before. Now, the implication of this, if you know anything about robot welding, is it typically takes an expert welder a week or two to train a robot welder to weld two identical pieces of metal exactly the same every time. It's very, very difficult. So to have a robot welder that uses AI and visual and IR and material temperatures to weld two things together almost perfectly that it had never seen is breakthrough. So I'm looking at this, and then something dawned on me that might be the 3, 5, 10-year future of AI. Permit me to go back and use another analogy. Food distribution is widely distributed. The growers, the farmers, everything is widely distributed in our world. And generally, it gets consolidated. Value gets added through canning and cooking and packaging. Those then go to giant warehouses, and then they start a distribution flow out to all of us. And sometimes it might be, Costco or BJ's. Sometimes it might be a local market. Let's take that same distribution for low latency data and say there's data that will grow all over the place. Some of it needs to be kept regionally. Some of it will be used across the planet. Right? Then we'll warehouse that and we'll have it in giant warehouses where people will extract some of that and add value. And some of those might be a legal AI. And then some of those will have to be distributed locally because of the latency requirements. And there'll be a little market for data that might be only a quarter mile from me. And so I think this thing that we're going through right now with AI might finally be the thing that has what the analysts have been talking about edge forever. This is the thing that might make edge happen. And there's some side benefits. The energy density is widely distributed, has less impact on the grid. They may produce heat that we need locally and nearby. So some of the things that are distasteful about data centers might go away if we become more widely distributed rather than giant data centers.
What I love about that concept, particularly that concept of like understanding the various elements of, let's call it, perceived waste in the data center and how it can be re-leveraged. It harkens back to that same point. The reason why data centers inherently are not necessarily seen as things that people want in their backyards or consumers of materials is because there's not that overarching kind of 30,000 foot view of where is this stuff needed? Like you think of a data center as producing all this heat and you have to get rid of it when, several feet away, there may be a community that could really make use of that heat. And they're not talking to each other. There is no, we use the word connective tissue a lot, but there is no network in between those two places. And a lot of the things that we're solving, that you were solving within the data center in the late 90s and trying to figure out how to leverage all that data, if we kept on going further and further kind of up the stack and saw that there's so much kind of overlap in terms of one man's garbage is another man's treasure, as the saying goes, that we're kind of on the precipice of finding ways to integrate with each other, both when it comes to data, when it comes to raw materials, and when it comes to how we're impacting each other's environments.
That I was talking about systems thinking. This is, there will be so many career opportunities for these, I call them the benign neighbors of data centers. If you think about it, if you could use even 50% of the compute for a benign neighbor to a big data center, that means 50% of that computation was free. If you think about this, and with liquid cooling, direct to chip and high density, we can almost cook vegetables right now. We can just about cook vegetables. So that's a pretty benign neighbor to a big data center.
So if you're really upset master welders who have been displaced by this AI, there's plenty of opportunities out there.
There are, absolutely. So a techie question. I mean, we talk about compute densities increasing. I mean, still we're somewhere around 10 to 15 kilowatts of rack space if you were to globalize that number. But then there's deployments right now that are more lab setting between 300 to 400 kilowatts of rack space. We also know that the current environments are not designed for high dense computing. And quantum is actually right around the corner, at least that's what I believe. I mean, probably within the next decade, that's going to happen, which means that we're not going to be computing at 400 kilowatts of rack space. The temperature threshold are going to change to, what was it, 495 Kelvin?
Right.
Once that gets into the equation, what are we talking about? I mean, what kind of compute density are we talking about at 495 Kelvin?
Well, negative 495. So just a few degrees Kelvin. I think back to systems engineering and technology is, wow, there's a blend of cooling and thermal and compute that everybody will need to utilize. Yeah, I think those densities will continue to increase for this reason. I was chatting this weekend on a bicycle ride actually with somebody, and they were talking about these chip densities. And I ride with technology folks. We were talking and I said, you can't buy a Pentium today, right? All you can buy is a multi-core high power CPU. You can't buy that other chip for your motherboard anymore. I suppose you could do embedded stuff. But the point is, with the chip folks making these fast turns of 6 months to 12 months, everything will be high density, whether you pack them together or not. Those will be 1,000-watt chips, and that's all you'll be able to get. And 1,000-watt chips and, in a couple square inches, they will have to be liquid cooled. So this technology will be pervasive, whether we want it or not, because the chips will get more compact. Will they be high density racks? That's kind of your real question. And I suspect that there, like all things, there will be a normal curve. Remember, I'm a mathematician. There will be a normal curve of a lot of it will be high performance, high density, because we figured out the challenges. And high density means there's a higher quality of heat to be taken. So those will likely persist. And then we'll have AI down in the basement next to our fuse box, probably.
And then the cryogenics for quantum even further down. We'll just keep on digging.
That's right. That's right.
So, Greg, you've had a very interesting journey, and thank you for being that weird uncle to continue to share and encourage the young generation and bring everybody
Is that going to be the
together.
title of this podcast?
The weird uncle from Ohio. Yeah.
One of the things that we are trying to solve for is the fact to encourage young people to come into our space. And we want to be encouraging people that this is the sector, this is just the beginning of the future.
Yeah.
Based on your experiences and how you've learned and made significant contributions to the sector, a couple of questions that I have for you is, how do you continue to stay engaged and top of the ever-evolving technology sector? And secondly, if you were to do this all over again, what would you tell the young Greg Ratcliff?
Okay. Staying involved, I think it begins with what you said when you opened this question, was this is rapidly evolving. It's a perpetually changing, a continuous improvement journey. And so it is not stagnant as a career at all. There is always change. It's always happened in our world. So there's not going to be any times to be bored. Now, I will say my experiences with the brighter the engineer, the less they want to grab the new stuff because they want to really get the most out of the technology they understand. And so there's always this tug of war that happens with technical staff. I love it. I figured it out and I can get 5% more for you. Like, well, we need 30% more. You got to throw away everything you know. So there's a little bit of that, which means it's exciting. I think as with engineers and programmers and other technology folks, they get a little bit further along in their career. They're like, yeah, the change is the fun stuff. It's not the perfection of what I already know. So at least in our world of data centers, all of it, power, cooling, distribution, in the future, heat reuse, that's a never ending journey of improving the world. And I think we're right at one of those times where we're going to impact the whole world with what we're doing.
And I think in your tone, there's an excitement. Some people are engineers or mathematicians, and they have a fairly dull, droll delivery. And you can tell how excited you are just by virtue of how you describe things. I could just see you riding the bike, huffing and puffing, screaming about, processors that you get today as you're riding your bike. It's Pentiums.
Can you believe it's 1,000 watts in this much space?
And I think that sometimes we miss the forest for the trees, where we talk about like people following their passions, and it's really kind of a checkbox. It's one of those things we say, a tagline. But in reality, whether you want to use the term lifelong learner or what have you, I think technology in general, if you look at this generation that's grown up in the digital age, they're addicted to it. And I think what they miss is because we came of age at a time when we saw it develop, we knew what life was like before this technology that they're addicted to. I try to explain it to my kids. They don't know what I'm talking about. I think we have a passion,
still,
right?
I think we are at the beginning of some massive changes to the whole world. Maybe every generation thinks that's it, but that's okay. This is the time for our generation.
No doubt. But I think exactly how you describe it, we need to like instill that wonderment. I think when, in your role, you get to see what's on the precipice. You get to see where things are coming. You have that kind of analytical systems oriented mind where you're like, look how cool this stuff is because we're all doing it. And I think what's missing in the way we train engineers today and the way we discuss careers is you're missing that passion. So we need to bottle up the weird uncle for everyone to see them and
Weird uncle school. Okay. Uncle and aunt school.
Right.
Sorry.
We're going to distribute like those food distribution. We're going to get weird uncle energy around the country and around the world.
Yeah.
Brilliant. Greg, this has been amazing. So glad we were able to spend some time together and get you on the platform. And thank you for sharing your journey and your insights. Lovely having you, and can't wait to see you in person again one of these days.
Yep. I'm looking forward to that too. And great to meet you for the first time, Phil. I'm sure we'll
Absolutely.
cross paths again.
No doubt.
This has been great. Nothing lasts forever. Markets will come back, currencies will rebound, businesses will go on, and we will all move on. That could happen next week, next month, or next year. At Nomad Futurist, we're confident that those who prepare rather than panic will come out of this stronger. Thank you for joining us. This has been brought to you by Nomad Futurist. Check us online at nomadfuturist.org And thank you for listening and subscribing, as well as your continued support.